The James Webb Telescope has provided the oldest and most precise image of Proxima B, revealing amazing information about this potentially habitable exoplanet. As we set out on an adventure through space to uncover the mysteries of Proxima B, we endeavor to determine whether it is the next Earth. This intriguing planet exists within the star's habitable zone. Proxima Centauri b isn't just any ordinary rock, it's a relative of Earth. Located just 42 light-years away from us, this planet is shrouded in mystery and wonder. Could it be another Earth with oceans and life that thrives on its surface? However, there's more to Proxima Centauri b than meets the eye. It isn't alone in its orbit around the red dwarf star, it has a companion. Who knows what other secrets the star system holds? Perhaps there's another planet that we have yet to discover. Proxima Centauri b essentially receives the same amount of energy from its star as Earth does from the Sun. Could this truly mean that there may be water on its surface, even life? As we expand beyond our own solar system, we encounter a vast universe of exoplanets, planets that orbit stars other than the Sun. With approximately 200 billion stars in the universe, the possibilities are endless. There are an infinite number of exoplanets, even some that wander freely, untethered to any star, space explorers that rebel like stars themselves. Among them all, Proxima Centauri b stands out as a particularly striking and fascinating planet. Its year lasts just 112 Earth days, and it orbits its star at a distance much closer than Earth is to the Sun. This indicates that probably one side of the planet is perpetually bathed in sunlight, while the opposite side remains in eternal darkness. Now let's discuss the star that Proxima b orbits. Proxima Centauri is a component of a triple star system with Alpha Centauri, which also includes Alpha Centauri A and B. Together, these stars form the closest star system to our own solar system. Alpha Centauri A and B are a binary system, appearing as one star in the constellation Centaurus, and are the third brightest stars in our night sky, with a magnitude of less than 2.7. Proxima Centauri, also known as Alpha Centauri C, is a red dwarf star located 21 light-years away from the other two stars, roughly 4 times the distance between the Sun and Earth. In fact, the name of the star closest to us, Proxima, means nearest in Latin. Discovered in 1915 by Scottish astronomer Robert Thorburn, Proxima Centauri, despite being our nearest celestial neighbor, is not visible to the naked eye. It has an apparent magnitude of 11.13, which is much fainter than the visible limit of 6.5. Nonetheless, don't let that fool you, Proxima Centauri is still a star to behold. Dwarf stars like Proxima Centauri are some of the most efficient in terms of energy production. They may not produce a great deal of energy, but the internal core convection processes keep them shining for trillions of years. In fact, Proxima Centauri will remain a stable main-sequence star for another 4 trillion years. However, the habitability of a red dwarf star like Proxima Centauri is still debated. For one, it is a flare star, meaning it experiences regular and intense variations in brightness. As a low-mass star, its habitable zone would be much closer than the Sun's, between 0.23 and 54 cents. However, it's not as livable as it appears. Proxima b is bombarded by ultraviolet light from its star, much stronger than the radiation we receive from our Sun. This radiation is so powerful that even the smallest hydrogen particles could be stripped away, not to mention nitrogen and oxygen. The fact that a planet is at the right distance from its star doesn't imply that it can sustain life. Proxima b may not have a stable climate, crucial for regulating temperature and maintaining a water-friendly surface. Without it, all living things would be vulnerable to harsh space weather, making life nearly impossible. So while Proxima b might seem Earth-like on the surface, it is far from being able to support life. Many remain skeptical, as various factors make it unusable as a place to live. The quest to uncover the truth about Proxima b continues, and some people still have hope. One instrument that has successfully captured astronomers' attention is the James Webb Telescope. After several delays, the telescope was finally launched in 2018 and will assist us in determining whether there is life on Proxima b. As with any other scientific endeavor, things are never as clear as they seem. Various modifications were required to ensure that the James Webb Telescope delivers accurate images. Abby Bend, a theoretical physicist at Harvard, explains that if a planet like Proxima b absorbs light from its star, it can also emit it as infrared light. The James Webb Telescope is specifically designed to detect infrared light, capturing images of this light on the planet's surface and searching for patterns that could confirm the presence of water or an atmosphere. However, what if the planet has an atmosphere that isn't conducive to life? The mere presence of an atmosphere doesn't guarantee the existence of life, cautions Ed Turner, an astrophysicist at Princeton University. Proxima B could be similar to Venus, with a thick atmosphere that is generally denser than Earth's, accompanied by extreme heat that would make it impossible for life to exist. The journey to unravel the mysteries of Proxima B isn't without its challenges. While the James Webb Telescope holds promise, there are other factors to consider. With costs mounting, astronomers feel the pressure to find a way to observe planets like Proxima B. The risks are great, but the rewards are even greater. The opportunity to explore the unknown and unveil the secrets of a distant planet that holds the potential for life is a pursuit worth pursuing. If the exoplanet were habitable, could we one day visit it? Being the closest exoplanet to us makes it especially exciting, like exploring our endless backyard. Even more enticing is the fact that it is roughly the same size as Earth, and its position in the habitable zone suggests that it might have conditions suitable for life. Proxima B's proximity also makes it a perfect target in our quest for life beyond Earth. With it being so close, it presents an incredible opportunity for interstellar missions. Imagine the chance to explore this Earth-like exoplanet. Although we can't yet go there, it is certainly on the radar for future missions as technology advances. It is one of the most thrilling quests in the field of space exploration. However, it's not an easy task. It would take 75,000 years for spacecraft like Voyager 2 to reach the Proxima Centauri system. Nonetheless, each discovery brings us closer to understanding the universe and our place within it. Proxima Centauri B, despite its many challenges, continues to captivate the imagination of scientists and dreamers alike. It stands as a symbol of hope, a reminder that the universe is vast, mysterious, and filled with possibilities. One of the most compelling aspects of Proxima B is that it sits at the crossroads of science and aspiration. While its habitability is debated, the mere fact that it exists so close to us, orbiting in the habitable zone of its star, keeps the question alive: are we alone? Research into Proxima B is not only about discovering life but about testing the limits of our technology and understanding. The James Webb Space Telescope, with its advanced infrared capabilities, opens a new chapter in this search. By analyzing the light that filters through a planet's atmosphere as it transits its star, scientists can look for key biosignatures, specific chemical markers like oxygen, methane, or carbon dioxide that may hint at biological activity. But even with such powerful instruments, the results are slow and data is complex. Scientists must filter out noise, account for stellar flares, and carefully interpret what they observe. The challenge is enormous, but so is the potential reward. Meanwhile, initiatives like Breakthrough Starshot are already imagining a way to get a closer look. Using laser-propelled nanocrafts, researchers aim to send small, lightweight probes toward the Alpha Centauri system at up to 20% the speed of light. At that speed, we could reach Proxima Centauri in just over 20 years. These probes, equipped with cameras and sensors, could fly by planets like Proxima B and send back real data from another star system. Though we're not there yet, the future is promising. Each step, every telescope, every mission, every piece of data, brings us closer to understanding what lies beyond our pale blue dot. In the end, Proxima Centauri B may or may not harbor life, but its existence challenges us to look beyond ourselves. It urges us to expand our horizons, literally and figuratively, and to pursue the questions that define our curiosity. Where did we come from? Are we alone? And what's out there, waiting to be discovered? The story of Proxima B is just beginning. The universe is waiting. And our journey is far from over. But they provide fascinating glimpses into the characteristics and composition of exoplanets. These distant worlds are most frequently found by observing the changes they induce in their host stars. The gravitational influence of an exoplanet can cause its host star to wobble, and this radial velocity can be measured. The Kepler Space Telescope, spotted by astronomers, used the transit strategy, determining how much a star's light has diminished when an exoplanet passes in front of it. This technique has provided valuable information on exoplanets, such as their size, distance, and temperature. Here are some fun facts. Did you know that more than 22% of stars like the Sun have planets the size of Earth in their habitable zones? Or that TRAPPIST-1 is home to 7 exoplanets with water and rocky terrain on their surfaces. In our solar system, exoplanets can also have natural satellites known as exomoons. With over 4,000 exoplanets discovered so far, we know they are plentiful throughout the universe. Hot Jupiters, with their mass and rapid rotation, are the easiest to find, but countless other exoplanets are waiting to be discovered. NASA's James Webb Space Telescope is revealing the secrets of the universe, one discovery at a time. This extraordinary telescope has been gathering data and capturing stunning images of the universe, revealing previously unknown wonders. Recently, It made headlines with a groundbreaking discovery that could alter our understanding of the universe forever. NASA disclosed that the James Webb Space Telescope has discovered the first and only evidence of carbon dioxide in the atmosphere of a planet outside our solar system. This discovery provides vital information about the planet's composition and development, offering us a glimpse into the universe's mysteries. This gas giant planet orbits a sun-like star 700 light-years away, and this finding is a significant milestone in our quest for extraterrestrial life. NASA Administrator Bill Nelson stated that this discovery offers a new perspective on the universe that we've never seen before, igniting excitement among astronomers and scientists worldwide. But that's not all. The James Webb Space Telescope has been recording extraordinary photos and collecting data about the universe in the infrared. The light from a young, outflowing protostar named 110 IRS-4 illuminates the cool, wispy cloud material, while the orange dots behind the cloud reveal the light from distant stars obscured by ice within the cloud. This remarkable study was part of Webb's Ice Age project, which aims to investigate how ice evolved from its formation to the development of cold comets. Additionally, the James Webb Space Telescope has mapped the inner workings of a dusty disk surrounding a red dwarf star, imaging it for the first time at these light frequencies in the infrared. This discovery provides significant insights into the formation of planetary systems and could help us understand how our own solar system was formed. The James Webb Telescope has offered unprecedented views of Proxima B, revealing exciting possibilities about this potentially habitable exoplanet. As scientists study this intriguing planet, which resides in the habitable zone of its host star, Proxima Centauri, they aim to uncover whether it could be akin to Earth. Located just 42 light-years away, Proxima B is frequently referred to as Earth's cousin. The possibility of water and life existing on its surface has generated significant interest. Proxima B orbits a red dwarf star, Proxima Centauri, which is part of the Alpha Centauri star system, along with Alpha Centauri A and B. These stars are the closest to our solar system. Despite the fact that Proxima Centauri is the faintest of the three, it's a stable star. Red dwarfs like Proxima Centauri have long lifespans and are among the most efficient in energy production, shining for trillions of years. However, they can also exhibit intense stellar flares that might pose challenges for any potential life on nearby planets. The habitability of Proxima is still up for debate. In spite of being in the right zone, it might lack a stable atmosphere essential for preventing harm to potential life from radiation and temperature extremes. Proxima's prolonged exposure to ultraviolet light emitted by its star could strip away vital elements like hydrogen, nitrogen, and oxygen. Despite these harsh conditions, many scientists remain skeptical, noting that while the planet appears Earth-like in size and position, the actual circumstances might not be conducive to life. The James Webb Telescope plays a pivotal role in investigating these questions. Launched in 2018, it is designed to observe infrared light, which can provide clues about the composition of exoplanet atmospheres. For instance, if Proxima B has an atmosphere that retains heat or contains water vapor, the telescope could detect these signatures. However, Ed Turner, an astrophysicist, warns that the mere presence of an atmosphere doesn't ensure the habitability of Proxima B. It could resemble Venus, with a thick, inhospitable atmosphere and extreme temperatures. The quest for understanding Proxima B is not without challenges. Observing exoplanets requires advanced techniques to counteract the glare of their host stars. Direct imaging has become possible with technological advances that now allow astronomers to glimpse the characteristics of these distant worlds. The gravitational influence of a planet can cause its star to wobble, leading to detectable changes, while the transit method involves measuring the dimming of a star's light when a planet passes in front of it. Beyond Proxima B, there are numerous exoplanets in the universe offering unique insights into planetary formation and evolution. Some of the most exciting discoveries include gas giants that can be significantly larger than Jupiter, as well as smaller terrestrial planets that might bear similarities to Earth. The variety of exoplanets that orbit stars include super-Earths, which can have rocky compositions and sizes greater than our planet, and hot Jupiters that revolve around their stars closely. As our understanding of exoplanets deepens, so too does our appreciation for the vast diversity of planets that exist in the universe. The potential discovery of exoplanets that are habitable, like Proxima B, has sparked excitement and hope in the scientific community, fueling a desire to uncover the mysteries of life beyond Earth. The James Webb Space Telescope, with its groundbreaking capabilities, is at the forefront of this quest. Its ability to investigate the infrared light produced by distant exoplanets is changing our ability to study their atmospheres, composition, and potential for habitability. As it continues to unveil new discoveries, the telescope is providing unprecedented insights into the nature of distant worlds, guiding us closer to confirmation of the existence of life beyond our solar system. These groundbreaking discoveries are not only reshaping our understanding of the cosmos but also challenging our definitions of what makes a planet potentially habitable. As data continues to stream in from the James Webb Space Telescope, scientists are developing more sophisticated models to interpret atmospheric compositions, surface conditions, and even possible signs of biological activity, also known as biosignatures. One of the most exciting aspects of this new era in astronomy is the collaboration between international space agencies, universities, and research institutions. Together, they are analyzing terabytes of data to detect subtle changes in starlight or identify chemical fingerprints that could hint at life-supporting environments. In addition to Proxima B, scientists have identified other promising candidates for habitability, such as LHS 1140b and Kepler 452b. These planets lie in the so-called Goldilocks zone of their stars, where temperatures could allow liquid water to exist, one of the key ingredients for life as we know it. The search for exoplanets has also sparked new innovations in technology. Instruments like adaptive optics, star shades, and coronagraphs are helping astronomers block out the overwhelming brightness of stars, making it easier to directly image their planets. Meanwhile, upcoming missions like the European Space Agency's Aerial, Atmospheric Remote Sensing Infrared Exoplanet Large Survey, and NASA's Nancy Grace Roman Space Telescope promise to expand our reach even further. Yet, despite these advances, many questions remain. How common are Earth-like planets? What are the true conditions on their surfaces? Are we alone in the universe, or is life abundant, waiting to be discovered just beyond our current reach? The answers may not come overnight, but every new image, every faint spectral line, and every subtle stellar wobble brings us one step closer. The James Webb Space Telescope, with its unmatched sensitivity and precision, continues to lead the charge into this unexplored frontier, reminding us that the cosmos is far more complex, beautiful, and mysterious than we ever imagined. As humanity looks to the stars, inspired by these discoveries, we not only seek to understand distant planets, we also begin to better understand our own. Earth, in all its richness and fragility, becomes a mirror in which we glimpse the possible diversity of worlds, and a reminder of how precious our planet truly is.